All right, guys. So you have a table. It looks like this one right here. So we can go back to the full present. There we go. So your table looks like this one right here. Now, today we're going to focus on how to take a table and turn it into, or figure out if we have direct or inverse variation. So the directions here say, use the table to classify the relationship as direct or inverse variation, then determine the constant proportionality. So we're going to start with this table, and we're going to figure out how to get our answer, how to figure out direct or inverse from there. So the first thing we need to do is remember what direct and inverse variation are. So, what's the definition of direct variation? I don't want the written definition, I want the equation. Okay?
The independent increases, the dependent increases.
So that's the characteristic as the independent increases, the dependent increases. That'll help us. So we can write independent increases, dependent increases. Thank you, Jamira. What's the equations? What are the equations?
Y equals kx.
Y equals kx. Thank you, Faith. And what's the other one? I'm going to come over here. Whitney, what's the other one? K equals y over x. Good. So those are our two direct equations, right? What's k?
The number of letters.
The constant from number, right? It's like a 4 or 7 or 0.3, right? Or pi, whatever it is. K is a constant number. Okay, what are x and y?
The independent and dependent.
Good, independent, dependent. Inverse, what does inverse mean?
As the independent increases, the dependent decreases, and vice versa.
Okay, good. So as the independent increases, the dependent decreases, and vice versa. So they kind of do the opposite things, right? Okay, what's our equation? Does anybody know? Jessica, you know the equation? No? Good, y equals k over x. Okay, Maddie, what's the other one?
K equals y.
K equals yx. Good. Okay, are there any questions about direct and inverse? Ethan, that make sense? Okay. So if it fits this form, it'll behave this way, right, Ethan? Okay. If it fits this form, it behaves that way, correct? Are there any questions? No. So we're gonna take what we know right there and apply it to these two tables we have over here, and try to figure out which ones are direct and which one is inverse. Or, as always, neither is an option. Okay. So looking at this first table, I'm gonna zoom in a little bit so you guys can see it. You guys have the same table, don't you?
No.
No?
Yeah.
Does it not let me zoom in?
Yes.
Oh, wow.
Is this a present?
Yeah. Too far.
Take less.
Guess we'll just have to go with that. All right. So look at this one. X is going -2, -1, 0, 1, 2. Y goes -1.7, -0.85, 0.85, 1.7. How is this one behaving? As X increases, what's happening to Y? Increasing. So what do you think it is?
Direct.
Direct. So this one might be direct. It's behaving like it's direct. Behaving like it's direct, correct? Okay. But do we know for sure?
No.
No. How can I know for sure? It has to do what?
The equation.
The equation. It's got to fit my equation, right? So I have an x and a y value. So what can I do to make sure it fits my equation, China? What do you think I should do with these? I think it's direct. What do you guys should do with these to make sure it fits my equation? We want to try to find our constant, right? Right? Luis, how can I find my constant? You don't know? Long, how can I find my constant? Okay, the top divided by the bottom. Now, I have x on top. Sure it's the top divided by the bottom?
No.
Bottom divided by the top. It's k equals yx, right? We know for direct, k equals y over x. Correct? So if I do y over x for each of these, then I can figure it out.
Can I use stopwatches?
The biology teacher already has them. Miss Moore?
Alright.
She has them already. Here. Mrs. Moore, she's in Miss Eachley's room.
Oh, alright.
How about that, guys? Alright, so if I do y divided by x, I can figure out if it's direct or not. Right? So, here, y divided by x, -1.7 divided by -2, right? Y divided by x, -0.85 divided by -1. Now, can I do 0 divided by 0? No, it's going to be undefined, so I can't do that one. So don't worry about that one. Okay? This one, 0.85 divided by 1, 1.7 divided by 2. That's why we need our calculators. Can we calculate all of these? Yeah. How? Put it in there. Okay, put them in there. Okay, try them out. Are they constant? Probably not. Long as doubting already. They're constant?
Yeah.
Did you do them all or just a couple of them? All of them. What do I get every time, Faith? 0.85. So, oh, not that one. So all the ones we did equal 0.85, right? So that means what's 0.85? That's my constant. So is this direct? Yeah. So it is direct. So then we know 0.85 equals y over x, or y equals what? Oh, not over. X is on bottom, right? So what do I have to do, Josh, to get the x off the bottom? Do I add, subtract, multiply, or divide? We multiply, so I multiply both sides by x. What do we get? You know, we multiply both sides by x. What do I get? It'd be kx, 0.85x, right? Since k is 0.85, we can just plug it in right here to get our equation. Right? So I plug 0.85 into either of my x's, and that'll give me my equation. Does that make sense, guys? Yeah? Okay. Let's take a look at the next one. X is increasing or decreasing? Increasing. What's happening to y?
No, it's increasing. No, it's increasing.
Neither.
Let's look here. Decreasing, right? So what do you think it is?
Inverse.
So this one could be inverse, right? Could be inverse. So if it's inverse, what do I know about my k? What does k equal? K equals yx. So if I want to see if this one's inverse, what should I calculate? Good, multiply the top and bottom, right? We should do x times y. If we can do x times y and get the same number every time, then is it inverse? Yeah. So -2 times -0.6, -1 times -1.2, 1 times 1.2, 2 times 0.6. Can't multiply error by anything. That doesn't work. That's an interesting calculator you got there, Lon. Does that have a calculator on it? It does? Really cool. Been looking for a watch calculator that has that much style. What is it every time? 1.2. So since every time we get 1.2 when we multiply, that confirms that this is a inverse equation, inverse variation, right? So this one is inverse. Okay. So can I write my equation for it now? We know k is what? 1.2. So we have 1.2 equals xy, right? Or y equals 1.2 over x. So those are my two equivalent equations. Does that make sense, guys? Yeah. Now, what if I thought this was direct, but I didn't get the same number every time? Would it be direct? No. What if I thought this was inverse, but I didn't get the same number every time? Would it be inverse? No. Since it's not inverse, would that make it direct? No. What would it be then? Neither. Now, what if I got direct, I thought it was direct, and I got a different pattern, so like 2, 4, 6, 8. What do you think I should do then? Well, not inverse. Okay. All right. You guys are going like that in your worksheet, where it's going to have another pattern. So when you do this division, you'll get a pattern. So it's like 2, 4, 6, 8. All right. It'll be some recognizable pattern. when you have some recognizable pattern, when you do the y over x or the x times y, you gotta do it again, but with instead of x, use what? X squared. Okay? So if you get some pattern with your products, try x squared. Okay? So you guys make a note for that. All right, are there any questions? Any questions?